I'm recording this video to help explain some concepts and one warning you might have seen while doing exercise 4 on global spatial autocorrelation. So right here I have the mass towns features showing the variable of population in 2020. I also have open the spatial autocorrelation tool, Global Moran's Eye, with mass towns as the input feature class. POP 2000 is the input field. A conceptualization of spatial relationships equal to inverse distance, distance method Euclidean, row standardization. If I run that, you'll see I get a warning. You can open the history to see that. And the warning here is number 853. And the text of that is the default neighborhood search threshold was 40,682.9978 meters. You might see a warning and think that something went wrong. Nothing went wrong here necessarily. This warning is simply making known to you what search threshold or value for the distance band, which was unspecified by the user, by me, what it ended up being. So if we return to the tool, you see that I didn't provide any value for the distance band or threshold distance parameter. What is that? If I hover the cursor on that little eye, get a rundown of what it's doing, and you can read that, and it might make sense to you. If not, it's worth doing a little bit more delving. But you can see, I can't move the cursor, but it says distance band or threshold distance, after that in parentheses, optional. So we didn't need to specify a number, but a number was used. So let's figure out why that number, 40,000 meters more or less, was used, where it came from. For this, I'll open up the documentation that's on Esri's ArcGIS.com website. It was linked in the exercise document. And we can see for this page on modeling spatial relationships, conceptualization of spatial relationships. One of these, the distance band, very explicitly makes use of a specified distance in order to weight features that are compared in our input data. So you remember that the Moran's Eye examines the value of a variable of this input field at a feature, compares how it compares to the mean, and how neighboring features, nearby features, compare to the mean in the data set. Now what constitutes nearby? What's a neighborhood? That's defined differently based on which conceptualization of spatial relationship you use, and also among features within the neighborhood that are considered. How are they weighted? Now in distance band, the comparison between the kind of target feature of interest and every other feature in the neighborhood is weighted equally up to a certain point. That point is measured as distance from the target feature. And the relationships between the target feature and any other feature in the data set that's located farther away than this distance are not considered at all. When you see this little diagram, you can imagine the vertical axis to be the weight of that relationship in the equation for calculating Moran's Eye, whether it's considered and its relative weight compared to other features in the neighborhood. And then the horizontal axis here would be the distance. So the distance band is a value on that horizontal axis beyond which features aren't considered. Now when I ran the tool, I had inverse distance set as the conceptualization of spatial relationship. And if you look at the diagram here, there isn't kind of a hard vertical line at any point. So in theory, every target feature could be compared to every other feature in the input feature class. It's just that the neighboring or nearby features to the target feature would have a much greater weight, the relationships between the target features and those close by features in the determination of a Moran's eye than do the ones farther away. Still, Esri recommends you generally want to specify a distance band parameter value just to reduce the number of required computations, basically to forget about these comparisons that have relatively very little weight in calculating the output. And in fact, they want you to use one so much. Really, they want the number of computations to be limited so much that they write, when no distance band is specified, a default threshold value is computed for you. So for us, that default threshold value that was computed was the 40,000 meters. Where did that number come from? There is another tool called Calculate Distance Band from Neighbor Count. I'm going to pull that tool up. I'm going to put as input mass towns, neighbors 1, distance method Euclidean. If I run the tool now, it generates a few values, no warning this time, and it gives 3 here. Minimum distance, 2,094 meters, average, 6,391 meters, and maximum distance, 40,678. So that's pretty close, this maximum distance, to the default search threshold we saw in Moran's eye. And really, that's the maximum distance observed for any of the features in mass towns between that feature and its nearest neighbor. So looking at it here, I'm going to say that's Nantucket. So it's about 40 kilometers to the nearest feature, whether that's north or to the west in Martha's Vineyard. And so using that value, or a number slightly above it, would ensure that the comparison between the value of Nantucket relative to the mean in the feature class and the value of its nearest neighbor here relative to the mean would be input in the calculation of the Moran's eye. Now, if you're looking at a target feature in the mainland and you extend the radius 40 kilometers, you're going to include quite a few neighbors in that comparison. But old Nantucket out here in the southeast would only have likely one included. So if that was a concern for you, if it wasn't just one feature, or if this feature is particularly important to you, you might want to revisit Moran's eye. I can do that through the history. And specify, say, 50,000 as your distance band. If you wanted to ensure that there were a set number of neighbors, you could rerun the calculate distance band from neighbor count and set maybe, the nearest 8. Or you could set k nearest neighbors as the conceptualization of spatial relationship. And for this, you see that parameter of distance band disappears, and you specify a number of neighbors. So let's see. If I try 50,000 and I run it, I don't get a warning this time. It wasn't that anything wrong happened before, but it assumes that I know what number I typed for the distance band, 50,000. And let's see. So when we use 50,000, we have an index of about 0.08 and a very significant z-score here, 10.79. If I return to the results from the first, our index was 0.09, and our z-score was also quite high, 10.17. So the difference in the distance band used, it didn't lead to substantial changes in the measurement of the global spatial autocorrelation, which you'll remember doesn't really reveal anything about individual features or sub-regions within the area covered by the input features. It's really just describing the whole, the global input feature class. Is it clustered? Or is it dispersed? Or is it kind of, are values of the variable randomly distributed, likely to be randomly distributed here throughout? So hope that helps. Don't get too worried about every warning, but in this case, it might be interesting to you.